Okay, in our last video, we left off with talking about the domain of a composite function or the composition of functions. And we said that in order for a value to be in the domain of the composition, it first needs to be in the domain of g of x or that inside function, and then the domain of that inside function needs to be in the domain of the outside function. I know that sounds kind of funny when I say it like that, but let's go through an example and I'll explain to you what it is that I mean. Let's take two functions. Let's take f of x is equal to 4 over x plus 2, and g of x is equal to 1 over x. So before I can determine what f of g of x is, let's first talk about the domain. Okay, first thing that we know is that x can't be 0, right? Because that would cause the g of x to fail. So I know for this part here that x can't be 0. So that is the first value that I need to exclude from my domain. And now let's go ahead and do that composition. So remember, in the function f of x, wherever I see an x, I'm replacing it with g of x. So I have 4 over 1 over x plus 2. Right? And there's a couple of ways you can kind of clean this up and solve this. You can go ahead and multiply every single term in the fraction by that denominator. Okay, or you can go ahead and combine these bottom terms into a single fraction. Either way you do it, it doesn't really matter. You should always come up with the same thing. So if you look, your common denominator here is x, so I'm just going to multiply every single term in my function by that. I end up with f of g of x is equal to 4x over, right, these x's cancel out, over 1 plus 2x. Okay, and now let's look at this denominator, and I say here, well, I know that that can't equal 0, right? So I end up with x as a negative 1/2. So I know that x cannot equal negative 1/2. And so my domain for my composition then would be this. I can go from negative infinity to negative 1/2. From negative 1/2 to 0, not including them, and then from 0, whoops, that's a positive infinity symbol, to positive infinity. Okay, so that's how you work through that domain issue. First, find the domain of g of x, or that inside function. Right, the letters that we use might not always be f and g. It might be h and k. It might be L and M, whatever it happens to be. Just first take the domain of that inside function, that piece that's inside, and then once you do your composition, then find the domain of that and make sure you exclude the values of both. A quick little review I do want to go over of simplifying that fraction. I know I talked about it really quickly. But that previous problem was this. We had f circle g of x was 4 over 1 over x plus 2. And I said the way that I showed you before was just take that denominator and multiply every single term by your common denominator. The other way you can do it is to combine this denominator into a single fraction, which would mean you are multiplying the 2 by x over x. That would give you 4 over 1 over x plus 2x over x, which would give you 4 over 1 plus 2x over x. Remember, that's just, division is just multiplying by the reciprocal, x over 1 plus 2x. And so that gives you 4x over 1 plus 2x, which was the same thing that we got here. Okay, it's just another way of doing it. I don't really care which way you do it. They're both perfectly acceptable, mathematically speaking, so you can do it whatever way you're more comfortable with. I just wanted to show you both of those ways of doing that. Okay, so that's how you go through finding the domain of the composition of functions. And you should be all set. I'll see you in the next class. Take care, everybody.